Hello everyone, it's Mahin. So in this video, I have a beautiful puzzle for you guys. The puzzle is taken from a book called The Art and Craft of Problem Solving, and it was written by Paul Yates. And this book is one of my favorite books ever, regardless of the genre. It's just a beautifully written book, and it will change the way you think about mathematics and problem solving in general. So if you are studying something or working on something that requires analytical skills and imaginative thinking, I will highly recommend you to have a look at this book. All right. So yeah, Paul Yates mentioned this puzzle in the second chapter of that book of The Art and Craft of Problem Solving, and he said that it was actually given in a software job interview. It's very interesting. So the goal of the interviewers was to see how quickly the candidates give up. Because as you'll see that when you first attempt this problem, it seems like there is no solution. There's no way you can solve it. So they basically wanted to see the resilience of the candidates. So it's quite interesting. Anyway, so without further ado, let's have a look at the problem. Look at the puzzle. So the question is very simple. So as you can see, there is a box and there are like 3 alphabets. So what you have to do, you have to connect each of the alphabets in a way so that they don't cross each other's path. That's why I named it the Uncrossing Path Puzzle. I mean, there is no official name, so I just named it this way. So yeah, this is the only catch. They cannot connect each other. So let's say I'm trying to connect C with C, right? So I'm connect C here, right? And then I'm trying to connect B with B. Now, how can I connect B with B so that it doesn't cross C? Well, I have to connect it this way. I have to bring it this way. But in that case, I cannot connect A with A, can I? Because if I want to do it, I have to cross this. Either they cross these 2 paths, or if I want to go this way, if I want to go this way, I have to also cross this path, right? So this is the catch. You have to solve it in a way so that they don't cross each other's path. So what I'll recommend you to pause the video and try to solve it by yourself. You can even exit the video if you want. You can take as much time as you want, like 1 hour, 1 day, 1 week, 1 month, or even 1 year. Because I know the amount of satisfaction that you will get when you can solve a puzzle by yourself. That's something unique that you cannot get by seeing someone else solve it. So that's why I'll recommend you. And on top of that, it doesn't require any extra skill. Unlike mathematical problem that requires you to know some mathematical theory, it doesn't require any mathematics. It's all about tinkering around the problem, tinkering with the problem. All right. So yeah, just pause the video and try to solve it by yourself. So if you did that, you'll see that. I mean, probably if you play around with the problem for a while, there's a possibility that you will find a solution. You will be able to connect each alphabet with each others in a way so that those paths will not cross each other, right? So it's possible, but I mean, there is no guarantee that how quickly you'll be able to do it, right? There's no guarantee that how fast you'll be able to solve it. So that's why we will not randomly try to tinker around with it. What we will do, we'll try to solve it in a very systematic way. So let's say whenever you try to solve a problem, it doesn't matter what kind of problem it is, mathematical, non-mathematical, and if you're trying to solve a problem, and if you think the problem is too hard for you, there is a beautiful strategy, problem solving strategy, that is called make it easier strategy. So what you can do if you cannot solve a problem, try to tweak the question, tweak some parameter, change some parameter in a way, and that will make the problem slightly easier for you, and you'll be able to solve it. So whenever you cannot solve a problem, try to find easier version of the problem that you can solve. And while solving the easier version, it's possible that you will see some kind of pattern, and then you can use the pattern to solve the original problem. All right, so that's the idea. That's the make it easier strategy. It's very effective though. I mean, its effectiveness lies in the fact that it's not really mathematical, skill. It's mathematical tool. It's more of a general strategy. So you can use this strategy in solving any kind of problem, mathematical, non-mathematical. So we'll try to use this strategy here. So we'll try to make this problem easier. So what is the easiest version of this problem? I mean, the difficulty of this puzzle lies in the fact that these two alphabets are kind of in the opposite, in the wrong place in a way. Like if I want to say this that way, like in the kind of opposite place. So let's say instead of it being like that, if it was like that, let's say, let me draw it here again. Let's say if the diagram was like this, A is here obviously, B is here, and then C is here. So instead of A and B being in the flipped position, let's say if A were actually here and C were actually here and then B were here, right? B was here. Then it would have been very easy, right? And just connect A with A, B with B, and C with C without crossing each other's path. But we cannot do it because, I mean, because of the positioning of A and C in the original diagram. So what we can try to do is that we can try to, as we already connected them, we can try to push them, we can try to rearrange them in a way that from this diagram and try to make this diagram like this diagram, right? So I'll try to push C so that C will come here, and then second step, I'll try to push A so that it goes there while being connected. So let me try to do that. So if I do this, let's see if I try to push C this way, how will the new diagram will be. So let me try to draw it here. So let's say this is the new diagram. B is obviously here. I mean, this we will not change this. We cannot change this because they are disconnected. B is connected here. So B, A, and this are connected here with the border. But I can push this C. My goal is to push this C here. All right. So what if I do this? All right. I'm gonna try to, let's say, draw C somewhere here. So I'm trying to push the C here. All right. And then while it's being connected, and then A is still here, connected, and B was here, right? So as I'm pushing C, so if I want to connect B, while it being the same diagram, it has to go like this. So the straight line will be a bit curved because I push C this way, right? Now what I will do is that I will try to push A that way, right? So let me do that. Now if I do that, let's see how it will be. So if I do that, I'm gonna erase this part right now, and then I'm gonna. All right. So I'm going to, my goal is to, because in the original diagram A is here, so we have C here and B here. I'm gonna push A this way. So let's see what we get if we do that. So we have C here, which is okay. See here. Let me first draw each of this. Each of these alphabets here on this side, and then my goal is to push the A this way. So if I do this, how A will be? Well, if A is here, it will go like this, right? Of course. But the problem is that as I pushed A this way, these two path, they has to be carved like this. So how they will be, they will be affected by A being pushed on this way. So let me draw that too. And C is here. C were here, right? In this diagram, C is here. So as I push this way, imagine if I push this way, try to imagine that. Imagine I don't have animation, so I can show it like while I'm pushing it. But try to imagine if I push this way, B will be carved this way and C will also be carved this way. So B and C both will be carved this way and they will go through this path, right? this path. All right. Now C was connected here with C. C will be connected here. So this is B, and then this is C, right? So C was connected like this. C will be like this, and then you cannot connect B here like this because it will cross C's path. So what can we do? We have to take it here and then connect B here. As you can see, we connected. If we compare this diagram with the original diagram, they're exactly same, and we connected all the paths together, but they didn't cross each other's path. So this is basically the solution. So we can also do it in the original diagram. So first let's connect A with A, and then we're gonna go via this little little road that we have, little gap that we have. We're gonna go this way and then this way, and then we're gonna first this is B basically. We're gonna first connect C, and then this is B, right? This is B because it comes from B, and it will go like this. So see, this is the solution. So as you can see, with make it easier strategy, it becomes so easier. I mean, it's possible that you'll be able to find the solution without solve it in such systematic manner. When I solved it, I didn't use this strategy. Actually, I was trying to play around with the problem, and then finally I solved it. But yeah, I mean, this strategy is effective because in real life even you have to face some kind of problem, some kind of situation where practical problem where you can try to find a solution by making it slightly easier, and then try to convert the idea that you get from solving the easier problem, try to solve the harder one. You can use it in, even if you're studying mathematics, if you're studying engineering, if you're studying physics, I don't know, like any kind of science, and you're solving a problem, trying to solve a problem, and if you find the problem to be a bit hard, you can try to make it easier, and then try to solve the easier version, and then it's possible that you'll find some kind of pattern that you can use to solve the harder one, right? So this video is not just about this puzzle, it's also about this make it easier strategy. Try to apply it in your particular discipline, where whatever you're doing. If you are studying something, working on something, try to use it whenever you face a problem. So yeah, I mean, that's the solution. I thought that was a very beautiful solution. If you were successful in solving it by yourself, congratulations. And if you couldn't solve it, it's okay. I mean, probably if you thought about for something more, sometime more, it's possible that you'll be able to solve it. It's not that difficult though. So yeah, that's basically the puzzle. I hope you liked it. Thank you so much for watching, and have a lovely weekend.